Hey friends, welcome back to Nelly Sisters YouTube channel. I'm Neha Nelson, a student of class 9. In today's session, we are going to look about what was the topic I want to say and speak and teach you today? Um, yeah, if you have any idea, comment below right now. Yes, in the previous video, I was able to speak about acceleration. Okay, and today I would speak and teach you about the retardation. As well as the previous session, I was able to say the applications related to the decrease in velocity in our day-to-day life. So let me just remember you once again them. Train arriving at a station. From it, I am going to teach you retardation. Train arriving to a station. In the last video also, I had just explained the little specification about the decrease in velocity, but I haven't even referred the retardation is that. But a little iconic things were given for you to understand that. But now I am going to understand and make you realize what do you mean by retardation. So, as I told you that when velocity decreases, the acceleration becomes negative, and a negative acceleration is known as retardation. Okay, so the negative acceleration is known as retardation. When will the acceleration becomes negative? When the velocity decreases. Sometimes you could have a doubt that the acceleration is a scalar quantity and retardation is a vector quantity, or retardation is a scalar quantity as well as acceleration is a vector quantity. No, clarify the doubt right now itself. It is that both of them are vector quantities. So as I told you that the decrease in velocity, the negative acceleration, which is known as the retardation, as well as a train when it is arriving to a station, we knew that far away from the station itself, the train will be stopped. The engine would be stopped. For what purpose? Think. Let's think, right? For what purpose? Comment the answer right now below. So let me give you the answer. Okay, here you go. It is because of that, as fast as it coming towards the station or moving through the railway track, now I'm speaking about retardation where displacement also takes place, which is a vector quantity where direction as well as magnitude takes place in a sequential way. Therefore itself I am going to take like that in a straight line distance. The train is moving very fastly. To reduce and to influence the speed of the train, we are pulling the engine within far away the station itself. To decrease the speed and to influence the speed, to decrease the velocity of the train, of the body, or of the object, to regulate the speed and to stop in the correct station itself. Right? So for that, over there, a decrease in velocity takes place. A negative acceleration takes place, which is known as the retardation. Have you understood it? Haven't you? Yes. Okay, so let's understand some examples for that, as in the case of questions for understanding retardation. So, an example is a vehicle is traveling at a speed of 5 meters per second. Is brought to rest in 2 seconds by applying brakes. Calculate the retardation of the vehicle. So we need to calculate the retardation. As well as we knew that the negative acceleration is known as retardation and the decrease in velocity. First thing you should do in these type of equations that I already said in the previous classes related to acceleration equations. First you need to write the key points, to take and write to the paper what all things are given in that. The main key things would be there for you to find the answer. In the question itself, there are certain things which would help you to find your answer. So first take it and write it. For that itself, you would get 1 mark just for writing the key things to take and write it from the question. That is an ethical thing, right? So now over, we could understand that here there is an initial position and a final position. Over there we need to find what? Negative acceleration, which is retardation. So we understood that the negative acceleration is retardation. Therefore we only need to find the acceleration. So first you need to accelerate, we understand acceleration, then you should convert it, we should not need it as in a negative acceleration. But the question as we knew that the equation of acceleration, before saying that, let's take the key points from the question. It is u, the initial position is 5 meter per second and the final position is 0 meter per second. As we listened to the question that when it comes to rest, it came to rest, right? It brought to rest, and the time taken, the time interval was 2 seconds. So over there something is there. What mean? What do you understand from that? Yes, over there you could understand that the in rest, whether the velocity is in rest or in rest, you could say that it is the 0. It is 0. So therefore the final position is 0 and the initial position is 5. Therefore the what is the formula and what is the mechanical process that is happening and what is the formula of our acceleration? Yes, as we knew that a is equal to v minus u by t, which is clarified in the previous sessions. So in the case of acceleration things, okay, just check out the channel. So the acceleration already given, right? So a is equal, not given, sorry, acceleration, sorry, a is equal to v minus u by t, the v is equal to 0 and 5 is the what? U, the initial position, and t is 2 seconds. Converting, and finally the answer would be it will be minus 2.5 meter per second. Meter per second only. No, won't write meter per second, which would become as the velocity. It is, or it would become an initial position or final position. The answer should be in a square, which means meter per second square. So minus 2.5 meter per second is the answer of this question. So this is the thing that over there a decrease in velocity can be seen, right? The final position became rest, and then you could say that the acceleration became negative, and this minus 2.5, the negative acceleration, is known as a retardation. So I hope you understood this case itself. So this is the main thing you need to understand about the retardation now. So in the next video, we would understand and study about the uniform and non-uniform acceleration and some of the traffic rules also, which would be given in the next video also. So right now I am going to end today's session. So let's see in the next session. I'm Neha, Sara Nelson. Subscribe, like, share and comment your ideas. Let's see in the next video. Till then, bye bye.